We are going to present today how we are going to do quantum computing on OpenShift or any Kubernetes cluster for that matter. We will start with first take a slide, introduce some concept, and then we will go and do a code session. So I am Parul Singh. I'm a senior software engineer at Red Hat. I work in the office of CTO. With me, I have Ismael and Luciano.
Hi, my name is Ismael Faro. I am the technical lead of the IBM Quantum Cloud and all the quantum services online. You are mute, Luciano.
Thank you. My name is Luciano. I'm a Python coder in IBM Research.
So let's start with the agenda. And first, we are going to give a brief introduction of the future of computing in how it's going to look in near future. And we will present an open source coprocessor model, a concept that can let you access quantum acceleration on cloud. And we would be talking about the key components that helps us build this open source coprocessor model, which are other open source APIs that let you access this acceleration. We will talk briefly about the key personas. It's always better to understand who are the target users are when you're presenting software or libraries. And then we will talk about OpenShift operators for quantum. And the one operator that we are going to discuss today is OpenShift Qiskit operator. We will give you more details what this operator does. And at last, we will have the demo. So for now and for a very long time, the bits have been the fundamental unit of information. But recently, we also had neurons that let you use GPU acceleration. But of recently, there's a newcomer around the corner, which is called qubits or quantum bits that can give us unprecedented acceleration in the field of computing. You can take from information and HPC. You can take hybrid cloud, biology, integrated automation, physics, information, you name it. So it is going to bring a revolutionary change in everywhere. So to start with, let's see what is the current school of computing. We have right now one of the most powerful supercomputers that is made of bits and neurons, and it is called, or it is at the Oak Ridge National Laboratory. It's called Summit, and it can do 200,000 calculations per second. It is made up of IBM Processor 9, NVIDIA GPUs, humongous file system. But the question is it enough to solve all the problems, or there are still untractable problems? And to give you a context, let me give you the example, which is of coffee. It is impossible to completely represent the molecular configuration of caffeine on today's most powerful supercomputer, but you can do that using just 160 qubits. So let's see if somebody wants, and they are very stubborn, and they say, no, I want to build a classical computer who does that. It would need 10 to the power 48 bits, and that is approximately consuming 1 to 10% of the total number of atoms in the Earth. So realistically, it's not possible. And that's why we think that quantum computing is going to provide a new path to solve some of the hardest or the most memory-intensive problems. So how do you consume this unprecedented power that we are talking about? One of the ways that we figure out is enable quantum workflows on Kubernetes and OpenShift cluster using a coprocessor model. And the coprocessor model is based on the concept that quantum computers are not there to replace classical computer. So I get to ask this question very often, Parul, when I'm going to have a quantum processor on my laptop? And the short answer is never. You will not have that in any time, at least till the time I guess I'll be alive. That may be a stretch, let's see. But you can definitely use quantum power on your laptop using the coprocessor model that we are talking about. So our idea is the CPU, the GPU, and the quantum processing unit, they're going to work in tandem. And we need to figure out a most efficient way to find the system where the classical computers will offload the work to quantum computers in the cloud. So This is not a very new concept, having a coprocessor model in cloud. We have already proved this using NVIDIA GPU specialized nodes on OpenShift. So think of it, it's already there. What we need to do is figure out what are the specialized tasks that is best suited for quantum computers. For example, if you ask a quantum computer to find the sum of two numbers, that is just silly because a quantum computer is not supposed to do that. So identify the task that is best suited for quantum computers and offload those tasks over the network to the quantum backend. And for this, we have started doing this investigation using IBM Quantum backend. So let's see what it takes to build a coprocessor model on the cloud. Well, as we have already talked, the objective is incorporating quantum computing from classical computing systems like OpenShift, Kubernetes, and just an FYI, we are not productizing this. This is just a prototyping. We are trying to define the best practice for running heterogeneous workflows in a coprocessor model using OpenShift and IBM Quantum services. So let's talk about the key component. And here is where, Ismael, your take.
Yeah, from our side in IBM Quantum team, we're working to create the quantum systems. That is obviously the hardware, the chips. That is one of the most important things that we need to achieve because from technical point of view, have a lot of challenge. In this moment, today, we put online more than 29, 30 devices in the last 5 years. And we continue to push new devices online every couple of months, because again, we need to continue to research about what is the new materials and new ways to make more efficient these quantum processors, because have a lot of challenge. No? From the other side, we continue to pay attention in the software, because obviously you have the hardware, but you don't have software. You don't have a lot of things to do. Our idea from the beginning was to incorporate or add a lot of layers on top of our hardware to allow to the people to have access to this hardware. We create an open source project that we call Qiskit, that allow to you, I'm going to talk a little bit more in deep in the next slide, but it's very simple. Allow to you to have abstraction layers on top of your on top of our quantum hardware. And on the other side, we start to create some kind of online services that allow to the people to have better access to this quantum hardware and connect the open source and the hardware using these cloud services. And the last big point that is very important for us is the community. You know, we continue to put a lot of focus to open this material to the research community, because like Parul commented, most of these things are research. We continue to figure out what are going to be, from the hardware and the software point of view, the next trends and the next big problems that we need to solve, and we are working on that. And thanks to that, we have an incredible community around the world that use this quantum hardware and the software. Next slide.
This is a video. Let me just share the link for this video.
Yeah, I can share my screen. I have the video here.
Okay.
I don't know if you can see my screen now.
Yep.
This video shows to you, this is all the executions that coming from all the places around the world that use our quantum systems that we have in the lab in Poughkeepsie and simulator. No, you can see the blue line is the real hardware, and the red line was the simulators that we put online to, obviously, in the beginning, we only have one device. Now, when we have more devices, obviously, the people use more the devices than the simulators. And this is the evolution in the last 5 years. And you can see that this video is from February of this year. In this moment, we pass the number of the 300,000 users registered in the platform. And you can see that there are a lot of people around the world. No? You are not going to be alone if you start to play with quantum computers, because there are a lot of community people around working with that. And this helped to us to move, let me stop sharing my screen, okay? And this helped to us to move our science to product, no? From science to product, no? Because obviously we continue to make a lot of science, looking for what is the next big challenge to solve in the quantum computers. The community is working to try to achieve this challenge, and from the other side, we start to create some kind of packaging with all these elements, and the premium users or enterprises start to test and play with this new paradigm of computation. The next slide. Yeah, okay, yeah. Like I said before, we have an open source framework that we call Qiskit, and part of all the demonstration and this idea about the operators on top of OpenShift is working to integrate this open source framework that we have with the rest of the ecosystem of applications around the world. And the idea here is from top to down, we try to make abstraction layers or levels that allow to the people to, from without a lot of knowledge about quantum or with a deep knowledge about quantum, have different flavors or different modules that the people can use and install. For bringing to you very simple examples, Qiskit allows you to, from the top level, implement or use machine learning algorithms or chemistry algorithms to simulate some kind of or simulate molecules, like Parul commented, or other optimization problems. After that, the next level is working in something that we call circuits, gates, and pulses. That is something that Luciano are going to show to you. After to create your circuits, your quantum code, you need to transpile or compile your code to attach or address better this code inside of these quantum computers. And obviously, we need to have some kind of tools to allow to experimentalist researchers to try to tuning and research about what happened in the hardware, no? Using something that we call pulses and other tools that allow to our researchers to continue to research in very low level. Additionally, we have this simulator that allows you to simulate and start to test things in local or on the cloud to accelerate the process, because again, there are few of these devices. There are not thousands of these devices, or quantum devices in this moment, and we need to bring some kind of options to allow you to, in local or in the cloud, simulate your code. And finally, something that we call IBM Quantum Provider that allows you to connect your Qiskit or the application that you create in your local machine or in the cloud with connect these solutions or this application with our quantum backends. Next slide. And in this picture, we try to show to you this stack, software stack, all these layers. And on the top, like I said to you, we have the open source part. We have other tools on the cloud that we call Quantum Experience and it's a Quantum Composer and Quantum Lab that allow to you to, in a very simple way in our web, start to touch and interact with these tools. We base part of this in OpenShift, and you can, that is part of this demonstration, you can deploy part of these tools in your environments using OpenShift. On the cloud, we have obviously the API that is the entry point for have access to all the services. We have this Qiskit as a service that is part of the Qiskit element that we put in the cloud to accelerate how you can use that. Connected to that, we have this near-time compute that is something that we are going to call from today Qiskit runtime, that are going to allow to you to take your quantum program and delegate the execution of your quantum program near to the quantum compute. That is the reason because we call this near-time compute, because it's side by side with our quantum processors. And obviously, we have this real quantum device that is the device that are going to make the execution of the algorithms from the quantum side. Next slide.
So now we know what are the components behind. Let's see who are the people that we're building these components for. So we divided the target audience or the target users into two categories. The first is the quantum algorithm scientist or the Qiskit programmers. And these are the people whose niche skill is designing or building quantum circuit to provide algorithm level functionality. They may or may not be your conventional software engineers who are very familiar with the nuances of setting up a development environment or figuring out the dependencies. And even if they are aware of all these nuances, our goal is to make this as easy for them so the ramp time to get started on developing quantum circuits should be minimal. And the second kind of users would be the traditional application architect or developer. And these are the people who design the entire software systems. And they are someone who have identified that there's a potential for quantum acceleration in their products or in their softwares or their solutions. And they would be building a next generation of softwares that would be leveraging combination of both classical and quantum algorithms. So let's talk about So let's talk about the OpenShift Qiskit operator. And we've been saying that you can enable quantum computing on OpenShift. So let's get our hands on what will help you enable. And basically, it is an operator. And if you're not familiar with the Kubernetes world and operators, it is basically something that has automated your installation and maintenance of a particular resource that we call as custom resource. And what the custom resource into play over here is a Qiskit playground. And the Qiskit playground is nothing but a Jupyter notebook that is enabled with Qiskit libraries for implementing quantum circuits. It also has some pre-installed Python packages that help you visualize the result. And you can run quantum circuits on simulator or as well as real quantum machines using this Qiskit playground. So I would give you a very a short description of what it actually does. So what the operator does, and then we will actually, me and Luciano and I are going to use this operator, but right now, let's just think that it sets up a development environment with an integrated Jupyter notebook. So let's say you are a user, you go to Operator Hub, you install the operator in your cluster. The operator creates a custom resource, which is the Qiskit playground. And using this custom resource, you can have as many as Jupyter notebooks as you want. And your quantum scientist would be using this Jupyter notebook. They would be either running the circuits on the simulator or actually calling the quantum backends. And we will also show how you can enable this calling of quantum backends.